Well, hello once again, everyone. Today we're going to talk about compound meter. Last time we talked about simple meter. Now, as you'll recall, in simple meter, beats, or the basic beat unit, whatever that may be, is divided into two equal parts. So in a lot of our meters, we have 4/4, for example. 4 signifies that there are 4 beat units, and the bottom 4 signifies that it's the quarter note that you're defining as the beat unit. You would subdivide that quarter note into 2/8 notes. So 1, 2, 3, 4 becomes 1 and 2 and 3 and 4 and something along those lines. And then each division is from there. In compound meter, we use a slightly different approach. It might help to think of compound as an additive idea. We want to have groups of 3 subdivisions together. So we know that 2/8 notes would equal a quarter note. And as you recall, if you want to extend the value of something by half of its own value, so if I have 1 and I want to add half to that to get 1.5, I add a dot. So if a quarter note equals 2/8 notes, then a dotted quarter note equals 3/8 notes. So if I see a dotted quarter, I'm supposed to think of that as being then subdivided into 3. Now, as we see in different situations, obviously context is going to be important, but if I define my beat unit as a dotted quarter, that means in the space of every dotted quarter note, I am going to have 3/8 notes, 3 subdivisions. So instead of 1 and 2 and 3 and 4 and, for a simple quadruple, a compound quadruple would have 1 la li, 2 la li, 3 la li, 4 la li, something along those lines. You may recall that I put something similar to this up last time, except I had quarter notes there at the bottom instead of dotted quarter notes. And that was to show how we identify number of beat units, note value that is serving as beat unit. Well, in this case, 2 beats of dotted quarter notes means that you'll have a measure of 2 dotted quarter notes. That would be a compound duple. 3 over a dotted quarter means 3 dotted quarter notes, a compound triple. And 4 over the dotted quarter means 4 dotted quarter notes, compound quadruple. But this is a little inelegant. We like seeing numbers. And although a lot of educational music will certainly print compound meters this way, in standard practice, this is not how we see compound meters. Let's think about this for a second. What number might we use to show a compound meter, or how a compound meter might work? I'm sure you all remember multiplication. Let's think this through for a second. A dotted quarter contains how many eighth notes? That's right, 3. So if you have 2 dotted quarters, how many eighth notes do you have? Well, let's use the power of science to help us here. Not that it's that hard. 2 times, for the number of beats, times 3 for the subdivisions equals 6. So I will have 6 eighth notes. So maybe I could write that, say, along these lines. Now the problem with writing it this way is that then this doesn't tell us the right beat unit. So we're a little leery about that. So bring that back to what it was. We know we have 2 dotted quarters, which equals 6 eighth notes. We don't want to put an eighth note down there specifically, but we can do something like this. When you see 6/8, that does not mean 6 eighth notes precisely. Yes, 6 eighth notes are in there. But what it really means is 2 groups of 3/8 notes each. 6/8 is equivalent to this. Let me zoom out just a little bit here. So perhaps my zoom. Here we go. Maybe we can see it, how it all lines up here. Let me do this a little more here. Maybe 75%. Yes. So we see a correspondence here. 2 dotted quarters, 1 la li, 2 la li, 1 la li, 2 la li is the same thing as 6/8. 3 would be 9/8. 4 would be 12/8. So let's take a look at how this actually works in real music. So I've got this blank piece of staff paper up here. I'm going to put some eighth notes in just so we see what's going on. I'm not going to overdo it here. Just you'll notice when I put these in how it's grouping them. I'll even put 2 quarter notes here at the end. All right, so I have a line of simple duple. Each quarter note would have 2 eighth notes, contains the same amount of space. I can even add this a little bit to show some equivalencies. Of course, half note takes up the same amount of space. You can get the rests in here so you can remember what those look like. So we can see some examples here. All of these are more or less equivalent. Now, take a look what happens when I go into 6/8, a compound duple. Now notice how the eighth notes are beamed here. Every group of 2 is beamed together. In this case, notice I see groups of 3 beamed together. And that is equivalent to this. Or possibly to this. Maybe even something along the lines of this. Dot there. Same principles at work here with simple triple. 3/4, a dotted half note will take up the same amount of space as, say, 3 quarter notes. I have enough room for 3 quarter notes. I can do a half rest with 1 quarter note, or I can do a quarter rest with something like this. Even mix it up and make a little more complex rhythm here so we can see. I like to keep them in line. We're not dealing with pitch yet, so there's no need to overthink this. So something like that. So for 3/4, we can see something like that. For 9/8, if I have a dotted quarter, how many eighth notes are in a dotted half note? How many eighth notes in a dotted half? Well, let's think about it. A dotted half contains a space of 3 quarters, as we've seen, but it also contains a space of 6 eighth notes. We'll revisit this in class because this is important, but I don't have the time here to go into why that is. So we need to fill this space somehow. We still have some space left, so we'll tie a note, and when you tie, you're basically continuing the note without re-articulating it. We need to fill 3 dotted quarters, basically. Well, this is how you do it. A full bar of 9/8, one sound all the way through, would simply be a dotted half tied to a dotted quarter. This will also contain 3 dotted quarters if we wanted to. It could contain the space of 9 eighth notes. And you've got the dotted quarter rest there taking the place of 9 eighth notes. And we even have a little swing to it like that. And we'll talk about this little swing rhythm, dotted quarter eighth, long, short, in class as well. And 4/4 would operate under similar principles. A whole note takes up an entire measure, 2 half notes. And any corresponding rests would be appropriate here as well. Now, sometimes finale will group 4 eighth notes together in 4/4 time. There's nothing wrong with that, but if you want to see the beat subdivisions clearly, I can show it to you like that. Whereas in 12/8, we have to cover the space of 4 dotted quarters. So 2 dotted quarters make a dotted half. What would 2 dotted halves be? That's right, dotted whole note. So this subdivision for here might look something like this. Now notice what I've done is I've added a dot to each of the note values in 4/4, and then we have, and this shows a subdivision into 3 parts. So that is essentially the difference between simple and compound meter. In simple, the beat units, whatever they may be, are divided into 2 equal parts, 1 and 2 and 1 and 2 and. In compound, the basic beat unit is divided into 3 equal parts, 1 la-li, 2 la-li, 3 la-li, 4 la-li. Now depending on tempo and things like that, it does not mean that one is necessarily faster or slower than the other. It just has to do with how the notes are subdivided. We will go over a few things in class that will hopefully clarify these things further, but this is the beginning of the process. And something else to consider is a quarter note or a dotted quarter note is not always your basic beat unit. It is possible to have, say, 2/2 time or 4/2 time or 6/4 time. And we'll talk about some of those things in class as well. I don't want to give away the whole ball game just yet. But this is a good intro, and if you have any questions, please bring them to class. Have a great day.